So now we're going to talk about non-inertial frames of reference. FR means frame of reference. Okay. Till now, all the equations which we got, that was A prime equal to A, V prime equal to V prime minus V. Okay. Now all those equations are in an idealistic world, which is like inertial. Okay. It follows Newtonian mechanics very well. Now here we are going to talk about accelerating frames of reference. Okay. So when you talk about acceleration, you might see that this Vt I have removed, because now we are going to use this formula which we all have studied in our, I guess, 9 and 10. It was class 7 for me in ICSE. Okay. This one, pretty famous formula by Newton. So yeah, there were 3 others. Now this is the one we need for now. So here we are going to assume that the initial velocity is 0. Okay. And this s is the one which we know is distance. Now the initial velocity is 0, so this part will become 0, and we get this half a t squared. Okay. So for now, this Vt which we had earlier is now going to get replaced with half a t squared, and everything else will be the same story again. Okay. Now we know from here we can again say x is equal to x prime plus half acceleration into time square. Okay. Now just like the earlier part of the video, we're gonna do the derivations of this by forming the differentiation of the equation. So from here, if I put the derivative, I'm gonna get dx by dt, which is gonna be v, is gonna be v prime. Okay. And you got half a d by dt of t squared, which is v prime plus half acceleration into 2t, which is v prime plus at, acceleration into time. Okay, pretty simple. Now we're going to move to the next part, which is forming the differentiation of this now, which will turn into acceleration, which is going to turn into acceleration prime. This acceleration is constant. Okay, so dt by dt will become 1, and this will become 1. So for differentiating this a bit, I'm going to write it as a naught, which is the acceleration of me with respect to you. Okay, this is a naught. Okay, I think I should mention it earlier. A naught. Yeah, it's better. Yeah. Okay. Yeah, moving on. Now you see that the acceleration has some value, like instead of the inertial frame of reference which we got, it was a is equal to a prime. Now we're going to start talking about fictitious force, or it's also called pseudo force, or it is also mentioned as something like false force. Now you might be thinking, what is a false force? How can a force be false? Like, it's said that the force does not exist, but it's applied. Now how does that even happen? Like, suppose I'm going through a pathway. This is the pathway I have. This is u. Suppose it's you and B is me. Okay, nothing prime, nothing all. Okay, you just are moving and there's a sudden curve coming, so you're going to take a turn, obviously. Suppose you're in a bus. Okay, and you got to remember the first postulate is said that everyone is at rest. That's what I said at the beginning of the video. Everyone is at rest. Okay, according to them, they are at rest. So you're moving in a bus. Now a turn is coming up. Now the bus driver has to turn towards the left side. Okay, so here you take the turn. Yeah, exactly. So come to my point of view. Okay, from my point of view, I will be looking at you moving towards a direction towards the left, and I'll be concluding that there is some force which is pulling you towards the curve. Okay, which is pulling you towards the curve and towards the center, which is called the centripetal force. Okay, I will mention it as CF, centripetal force. Okay, now this centripetal force is what I observe. Okay, but what is happening with your point of view? Okay, you are supposed to be at rest. Okay, but when you move and you take the turn, you feel a sudden force. You have moved till now here. You feel a sudden force which is throwing you outside instead of pulling you inside. This is, I will mention as CG, centrifugal force. Okay, but you are supposed to be at rest, right? I mean, you think that you are at rest, but then suddenly a force is applied on you and you are like, surprised. What is this force? Where did it came out of nowhere? Centrifugal force? You are not expecting that to happen. And from my point of view, neither am I even observing centrifugal force. I don't know what is centrifugal force. I am only saying something which is like centripetal force and is moving you towards the center, okay, not away from it. But for you, you are thinking that neither centripetal force should act on you, neither centrifugal force should act on you, because you are supposed to be at rest. So suppose you come down from the bus and you come towards me and you ask me that, did you see some force being applied on me? And you are like, and I am like, yeah, I saw a force being applied on you. That force is the centripetal force, which was pulling you towards the center. But you will be like, there was no force which was pulling me towards the center, but a force which was throwing me away from the center, and that was the centrifugal force. So for me, centrifugal force is irrelevant, since I did not even observe something which is throwing you outside. I only observed something which is pulling you inside. And for you, centrifugal force would be irrelevant because you were expecting no force at all, because you were thinking that you were at rest. So from here we get the concept of fictitious force, and we very famously know why centrifugal force is very much called a fictitious force. This is the concept of fictitious force in the form of relativity.